Hi, MC Bling Daddy here. Welcome to my worlds. This video presents an update to my tool, the Minecraft coding engine, CE. A disclaimer, keep in mind it's in no way directly connected to Mojang or Microsoft. However, I feel it does provide some additional coding functionality to Java Minecraft. It's potentially used by a player to generate Minecraft command blocks in a manner consistent with higher-level programming languages. It was created to allow and simplify producing command blocks in Minecraft that would mimic running equivalent pseudocode. This would hopefully require no access to the file system or, eventually, even to the server running a world visited by the player. It would only require entering commands in the Minecraft client running on the player's own PC to create command blocks in that world. So, from that point of view, it would require op privileges or cheats there. If you would like to get a feel for the original coding engine, I suggest you have a look at some of my previous videos on it. The original coding engine was to be generated by the player from text available in comment sections of previous videos and entered in the Minecraft game window in the command box or alternatively in the server interface window. Previous videos show how to do that. The coding engine consisted of a set of command blocks organized by function, each function comprised of a line of modifiable command blocks, each of the blocks separated by redstone repeaters, present to slow down the sequence so viewers could actually see blocks being activated one at a time. The player would modify the command blocks as needed, then execute them to generate additional command blocks in the world that would carry out the processing of the equivalent pseudocode that they were ultimately derived from. See previous videos for details. The current update converts the coding engine and the code it produces to use chained command blocks to optimize and speed up execution. If you decide to use the revised coding engine, setup and world insertion is the same as for the old version, and you can find instructions linked to videos from my homepage, MC Bling Daddy. Let's take a quick look at some of the differences in appearance and usage of the revised coding engine. If you have difficulties with some of the names and concepts in the current video, you may need to review previous videos explaining how the original coding engine was constructed and used. Now, most importantly, we're using chain command blocks rather than repeaters and impulse command blocks. In the previous coding engine version, we used signs to mark important command blocks, such as ones that needed to be changed before coding engine execution. Now you'll see mostly armor stands. In coding engine command blocks requiring code changes and marked by armor stands, you'll now find change items bounded by less than and greater than signs indicating items in the command that need to be changed before coding engine execution. This is rather than example values that might be used, so you have a clearer indication of what needs to be changed. It is presumed that you're familiar with the commands being used, though, and that you have pre-existing knowledge of what needs to be entered into the command. Next, let's take a look at how the coding engine might be used to produce chained command blocks and some problems that arise. Redstone torches are used for transfer of control by the coding engine. If setting a redstone torch is used inside a chain command block to transfer control to another location, the chain it's executed within will nonetheless be completed before the command blocks triggered by the redstone torch are executed. A queue is set up as redstone torches are placed. Once the original chain is completed, the redstone torch activations are executed in order as they arrived. If something else is executed in the original chain, It will happen before the redstone torch triggered processes are carried out. Let's look at an example where a couple of redstone torches are set within a chain along with an action that will affect how the others play out. First, starting at the entry point main, a redstone torch is set to trigger a second chain starting at armor stand sub 1. That chain sets a gravel block at a marker, the world cursor WC. Then, within the first chain, the world cursor is moved to raise it up a couple of grid coordinates in height, Y. Next, at the end of the first chain, another redstone torch is set to continue execution in a third chain at sub 2, and the third chain sets another block, sand, at the cursor, then sets a redstone torch at main to restart the cycle. If setting a redstone torch caused immediate execution where it's placed, then a gravel block would be set immediately. The world cursor would be elevated, then a sand block would be placed. When the cycle is repeated, a gravel block would be set at the new world cursor location, replacing the previous sand block. The world cursor would be lifted again, and a sand block again set at a higher level. But again, repeating the cycle, a gravel block would replace the sand, and then sand would be placed higher up. So, each cycle, gravel replaces sand. Let's see what happens. We'll start off by placing a redstone torch at main. As you can see, sand actually replaces gravel. This is because, even though a redstone torch is placed at the second chain, sub 1, the command in the first chain, main, to raise the world cursor is executed first. Then a redstone torch is set for the third chain, following the second chain in the redstone activation queue. Thus, after the world cursor is moved, gravel is placed, then sand, to replace the gravel, every iteration of the loop. So, you have to be extremely careful using redstone in a chain to transfer control, understanding, again, that the original chain is completed before any externally triggered chains begin their execution as part of a queue. Typically, in the coding engine, a chain ends followed by a space, possibly with an armor stand for reference, and then an impulse command block for starting the next chain is found just after the space. Either a redstone torch is set into the space by the last block in the chain, or the armor stand is referenced externally, and a redstone torch is set at its location to allow control that was transferred out of the chain to be transferred back to the impulse command block. The impulse command block will use a set block air to remove the redstone torch. Plus, it will activate the next chain, allowing anything previously started with a redstone torch to run before the next chain is activated. So, a suggestion: only set redstone torches at the ends of chains, or only allow a single sequence of command blocks to be executed in a known order, or else very carefully plan the sequence by which redstone will activate command block chains. Another thing, a redstone torch remains until destroyed, so don't expect a set of redstone torches all set at the same place before the first triggering event can be executed to cause multiple executions of the same command blocks. Now consider, for example, the set functionalities. 4 vars are entities with multiple objectives. For example, I cur, I fin, I ink. Variables are objectives belonging to the single entity var, var, with single values. For example, var s, var a, var u. So setting I to s would be handled by setting i's current value, cur, to s using the command scoreboard players operation I cur equals var s. Several variations are available with set using the same coding engine set command. Make sure you use a full specification. Similarly, a TP teleport operation has several potential forms and can reference a location or an entity or a location relative to an entity. The switch is actually only a phantom pseudocode statement at this point, as no memory of any parameter is carried forward statement by statement to the case statements. It really is only used for formatting to clarify and offset the cases. A switch end in the pseudocode would actually represent a return set point so that cases could transfer to the set point after completion to continue execution. But it is possible for a set of cases not to require a transfer to a set point, since a Minecraft chain of command blocks will transfer control through the entire chain, whether anything executes or not, and can trigger the execution of chained command blocks that follow and are directly connected without requiring a redstone torch to trigger continued execution. In this case, a switch fin might be used in the pseudocode, which represents no command blocks, and is also simply used for formatting to offset the case statements. The only real complication involves tests by case functions. Case tests store the result of the test, could be numeric comparisons or entity existence, for example, in a storage descriptor test result with values of 0 or 1. When used within a case, commands test the case's test result itself, and execute if the result is 1, and do not if the test result is 0. Then the test result is reset by the next case. Because of this, nesting switch, actually case statements, in line in the chain would cause the loss of the outer test result. So, unfortunately, nested switches can't be used as the coding engine currently works. As opposed to some programming languages, it is possible to execute more than one case, or even none. But you'll have to take care that execution continues along exactly one line after the switch finishes, or otherwise you could end up with execution halting, or even running multiple threads simultaneously. The best bet is to make sure the case tests are mutually exclusive and that they cover all possible eventualities so that at least one case executes. And a note, if a call is made within a case, the sub-called, not the case, should return to a switch end location that's placed after the switch cases. If there is a mix of calls and non-calls from within the cases, the non-calls still need to transfer to the switch end. Otherwise, the switch structure is such that no transfer to a switch end is actually needed from within a case, as long as the command chain holding the switch cases is directly connected to a command chain that continues the execution. In this case, in pseudocode, a switch fin could be used that generates no Minecraft commands and is used only for formatting to indicate the end of a switch statement. Well, that's about it for now. Good luck building your chained code and commands. Although I may have a simplification for all this in the near future, it's still important to understand how chains and redstone torch transfer of control interact. Thanks for watching.